G'day, you eight. How you going? Welcome back to another video. Today we are looking at the volume of prisms and how we can calculate that. So we're no longer counting cubes or anything like that. We're actually using formulas and working out how we can calculate exactly what the area of a shape is. So for prisms, the volume is equal to the area of the front face times its height. Now, a couple of disclaimers here, okay? Area of the front face isn't always on the front, okay? So this is just referring to the face that has that consistent cross-section throughout, okay? So it could be on top, it could be on the side, it could be in the front, okay? Remember, with a 3D object, you can always just rotate it in a way such that the face that you're wanting to be, that has your consistent cross-section, is on the front. Okay, and similarly, the height isn't always vertical. That height could sometimes be vertical, it could sometimes be the depth, it could be the length, the width, etc. So area of the face that has that consistent cross-section, and then times by how far back that goes in whatever direction that may be. So for example, okay, the volume of this, we've got our area of 40 centimeters and we've got our height of 3. So the volume is going to be 120. And then in this case, because volume has 3 dimensions, our units are in centimeters cubed. Okay, the power of 3 kind of symbol there refers to the 3 dimensions that we use to measure. So a centimeter cube has 3 different dimensions. That's why we have the 3 there. Volume equals, so this time the area is 24 times 5. Okay, so this time we have it on the front and the height is the depth. Again, we just got to sort of recognize that height isn't necessarily a vertical distance. So we put that into our calculator, we get 120 centimeters cubed. Okay, make sure you get those units right. And then finally, here we have the volume. The area of the face is 15. The height is 8. Okay, so we get 80 plus 40. It's also going to be 120 centimeters cubed. And you can see all of these different prisms end up with the same volume just because of the way that the area and the height interact to give us 120 centimeters cubed each time. All right, now for some of these shapes, you're not given the area. You actually have to first calculate the area of the front face first and then multiply by the height. Okay, so for this one, the area of a square is just its side squared. So it's going to be 3 squared is the area part, and then the height is also 3. Now we could have just written 3 cubed and that would have been correct, but I just want to show you that this part is the area and this part is the height. So we get 9 times 3, which is 27 centimeters cubed. For this one here, the area of the front face is 3 times 10, and then the height we just times by 8 again. So we get 30 times 8, which is going to equal 240 centimeters cubed. And then finally here we have a triangle. Now we've got to remember our triangle area formula here, which is half base times height. Now this is where it gets a bit confusing because the area of the triangle formula has height and then the area of the prism has height, but those heights are actually different dimensions in different directions. So don't be bothered by height. It's just one of the other directions or dimensions of the shape. So here we have volume equals half times the base, which is 5. The height of the triangle is 10. And then the height of the prism is 14. Okay, now we can put that on our calculator. We get 50 times a half, which is 25, times 14. Let's just put it all in just to be sure. So half, which is the same as 0.5 times 5 times 10 times 14. And that gives us our volume of 300 and 50 meters cubed this time because the dimensions are in meters. Okay, so when you're doing this part was the area, and then this part was the height of the prism. So just you want to sort of, as you write it out, think about the area first and then times the height on the end. Okay, finally for today, we're looking at composite solids. Now, a composite solid is a shape that's just made up of two different shapes or more. So what we need to do is split these shapes into bits that we can then calculate them separately. So what I'm going to do is I'm going to divide this up here. And we know that if that whole length is 20, and then that length is 8, then we're going to be left with 12 centimeters here for that dimension. So we've got V1 and we've got V2. So the total volume is going to be V1 plus V2. We write that out first just to sort of show exactly what we're doing. And then we can substitute and work out the values for each of these things separately. So the area of the front face of V1 is going to be 15 times 12. And then the height, that's the depth of this shape here, we can see it's down here is 5. So we're going to times it by 5. Okay, that's V1. And then for V2, we've got 8. And then the height of that thing here, if we think about that height is 11, the total height is 15, so that height's going to be 4. So it's going to be 8 times 4, and then the height, which is 5, as the same. Okay, and then we put that in our calculator, and we will get the total volume of this composite shape. So 15 times 12 times 5 plus, make sure you get your times and plus right, 8 times 4 times 5 equals 1060 centimeters cubed. Okay, so a few things to make sure you do right here. Split the shape up and make sure you get all the dimensions right. And then separately work out the volume of part of that shape and then add on volume of the other part. Okay, for part B, we've got a few different ways we can do this. I'm going to zoom in a bit and split this down so it becomes a square and a triangle. So what I need to do is I need to work out the dimensions that I'm missing here. So we know that this top part is 24 as well because it's the same as the height of this dimension here. So that means this bit here is going to be 10. Okay, so we've got area 1 and area 2. It doesn't matter which one you call area 1 and area 2. So, sorry, volume is what we're doing, not area. So the volume is going to be equal volume 1 plus volume 2. And the volume 1 is a triangle. So I need to do the area times the height. So the area of the triangle is half times the base, which is 10, times the height of the triangle, which is 24. And then the depth, okay, or the height of the prism is 16. Okay, for volume 2, we have a square, so the area is 24 times 24, and then the depth or the height of the prism is also 16. And then we can pop that all in our calculator. So we get half times the base times the height of the triangle times the height of the prism plus the area of the square times the height of the prism. And that gives us the following answer, 11,136 meters cubed. Okay, so good luck with the work today, guys. I'll catch you later.